Wonderful. Well, thank you guys for joining us today. We are going to be talking about the Repowering Schools new vertical axis wind turbine research project in partnership with FedEx. This is a research opportunity for university college and community college students in Florida that's going to introduce them to the fundamentals of power engineering and kinetic renewable energy technologies through hands-on experiential learning. Through this, schools will receive a vertical axis wind turbine and the associated hardware for conducting research of the school's choosing. The schools will also be able to receive a small research grant to help offset the costs of other equipment purchases or staff time. And through this process, Repowering Schools will connect the schools with industry mentors and help them guide them through some of this research. And we will offer the opportunity for students to present at a symposium during the Distributed Wind Energy Association conference in DC next year in February. The proposal is going to be due on April 20th, and the link is here below. And after that, we expect to be able to announce the winners of these research grants and research projects at the Clean Power Conference in San Antonio on May 17th. Just to reiterate the eligibility here, we are excited to have any undergraduate serving university, college, or community college in Florida to apply for this. There's no specification on department, so it could be any department on campus. We actually really encourage a diversity of departments since this type of research tends to be very multidisciplinary. We are really looking to expand the engagement of academic institutions with power engineering focused educational programming, but that have limited engagement with renewable energy technologies and with repowering schools. So we're looking to really find those schools that are ready to get into this and get their foot in the door with some new research. And again, this is a technology package that is a vertical axis wind turbine, but we're not necessarily looking for wind energy specific research. And we'll get into that a little bit more as we talk more about the technology package. So with that, I'm going to turn it over to Charles Newcomb.
Thanks, Remy. So this is a fun opportunity, and one of the questions you may have is, well, why are you providing us with a wind turbine if it's not necessarily requiring a wind-specific research? And the answer is that, well, these were some units that became available, and they have some valuable components to them, but they're not actually certified. So you may have heard of certification like UL certification. If you look underneath Amazon Echo or under your toaster or any appliance that you plug into the wall, it's going to have a little stamp on it from the underwriter's laboratory, which says this is a safe thing to have in your kitchen. It's not going to shock you. It's going to do what it's supposed to do. And wind turbines have a similar certification process where there's a certification body that says this is a safe, tested piece of equipment that will do what it says it's going to do. It's going to produce what it says it's going to produce. It's going to do so safely, and it'll last. Just because something isn't certified doesn't mean it doesn't have potential. It just means it's not certified. And so we as an organization have a policy of not necessarily recommending uncertified equipment for unattended operation. And of course, that then begs the question, well, is attended operation okay? And that isn't, the answer to that is yes, because it can be a test turbine. So how else are you going to certify something if you don't test it? So this is your opportunity to play a role in that. So that's the sort of, it's not legalese. We do have a lawyer here, but the intention is that to recognize, because of the lack of certification, we need to just be careful because it hasn't passed those tests to our knowledge. And it doesn't mean that somebody hasn't done testing and they don't feel like it's confident, they're confident in its ability to provide power safely, but just that a certification body hasn't had an independent test data set come its way. So it's a vertical axis machine, which means that the axis of rotation is vertical, so it spins I don't know what else spins that way. But it spins about the vertical axis as opposed to a traditional horizontal axis. And
Usually
there's
say
all
like an egg beater is how
like
I
an egg
usually
beater,
describe
yes.
it.
Although, how many people know what an egg beater looks like anymore? It spins like a blender.
Your KitchenAid mixer.
Your KitchenAid mixer is a vertical axis. Yeah. So the fun thing about vertical axis machines is that they don't, there's no direction requirement for wind. It can kind of harvest wind from any direction. That's kind of fun. It's a high solidity device, which means that you can't see through the rotor. And what that means is that it's really, so high solidity devices are very good at harvesting low wind speed energy. But they're not aerodynamic in the way that they're not lift devices. So they don't perform as well as typical lift devices in higher winds, but they're good in light winds. And so for Florida, that might be surprisingly sufficient. So that's something that we're interested in people finding out. There's a list of specifications there. And I think the main thing is that it's its size. It's a few meters tall. Its weight. It's not super light. It weighs a couple 100 kilograms, if I'm not mistaken. I can't see it now. Do you see it? Anyone else see it? 290 kilograms.
290 kilograms.
Yeah, so it's kind of heavy. And it's 2 kilowatts as its output. And it does say it's a 3-phase generator output, but that's just a typical permanent magnet alternator configuration, and it's a single phase output. So single phase 240, if I'm not mistaken. So it's a relatively small from a power perspective. Let's go to the next slide and see what we see there. And here you see a power curve. And the power curve is the relationship between wind speed and the electrical power that comes out of the turbine. And there's a few fun things that would be neat to test. Like number one, does it actually meet this power curve? Until someone certifies it, that's always up for debate. And so you also notice that it kind of follows a little bit of the cubic curve, which indicates that it's presumably efficient during most of its operation, and then it hits a max at 2 kilowatts. And the question is how does it do that? And so typically there's some sort of electromechanical braking, or there's, for Savonius turbines like this. So that's the power curve. And that sort of shows that they expected to make 2 kilowatts. And then there's the components. And then this is the kind of where we step into saying, okay, well, if you don't have enough wind, what else could you do? Does it mean that you can't play? You don't have any toys for the sandbox? No, the answer is you can play if you part it out and use different components to do fun things. And that's where Ian comes in. He'll be talking about that in a minute. The bearing cover, probably not much you can do with that, except for you are in Florida, so you could play in the sand with that. There's a vane, which we don't really know what the wind vane is. It's aluminum, so I thought it had a plastic, but maybe it does have an aluminum Savonius collector, if you can call it that. It's got a bracket. I don't know what you can do with that, but the generator, that's the interesting part, because it is a 3-phase generator, which will have an electrical output when you spin it. So suddenly you can use it to create power, or if you can feed it 3-phase power, then you could actually use it to drive something. So it could be a nice 2 kilowatt drive motor for something. And the hope is that anything you do with it will be something around renewable energy. And since it has moving parts like a generator, not like a solar panel, since it has moving parts, then the expectation is that it'll be some sort of kinetic renewable energy, whether it be tidal or wave or wind or something else, or running water. If you can find enough topography in Florida that you'll have running water sufficient head. Let's go to the next slide. I think there's one more, a couple examples of where they're set. And these examples here, it's architectural, it's kinetic art. And as to how much energy will actually make, again, that's debatable until you test it and until someone certifies it. But these are very popular from an architectural perspective because they just look different than a typical horizontal axis 3-blade upwind wind turbine. They look kind of fun. But it's really important from the certification perspective to recognize that before anything gets deployed in settings like this, where it looks kind of unattended, and there may be an expectation that'll make power that it get tested. So that's just our plug for testing, because these things aren't necessarily cheap, and putting wind turbines on top of buildings is fraught with issues. So it's important that they be safe around people. So I think that's the end of the technical turbine section, and on to you, Ian, correct?
Yeah, exactly. So thank you, Charles. So as Charles mentioned, we're through this project, we're planning to provide you with one or more of these turbines that can be used for research at your lab, at your university or place of education, community college. And so certainly if you're interested in working with a vertical axis wind turbine, that's fabulous. And we're excited about universities and educational programs that want to do that. As Charles said, these really are not devices that are expected to be put up and provide power to your campus or provide power to your school. That's not what the goal of this project is. It's to train and educate people in the technical aspects of power generation, power electronics, renewable energy. And that's really the focus of the work that we're trying to do. So again, putting up a wind turbine and operating it in a research experiment, lots of fun measurements, lots of fun experiments that you could do. But we also understand that might not be applicable to your educational institution. And there are other things that you could be doing. If you're in an urban environment where the turbines won't necessarily make sense, or you're in a low wind speed area, so you would put it up and it wouldn't spin. There's lots of other fun things that you could do with this equipment that would enable a good hands-on expertise for students. And so looking at resilient local power systems and the design of those in testing, as Charles mentioned, these are motors, and so you could run it with a variable speed drive. You could get two of these things and put them back to back and use one to power the other one, and start looking at off-grid energy systems for resiliency. How could you use this technology to provide your school or maybe a local fire department with backup power systems, and what would that look like? The kind of control of hybrid power systems, matching up a rotating machine, this case a wind turbine, but Charles mentioned water technology. How could you do this combining it with solar and then other spinning technology, diesel engines or something of that nature, again simulated in a laboratory area using these the components from these wind turbines to look at how you could provide backup power for small systems. The units come with an inverter, and so having a power electronic inverter, another great tool to just play around with different elements of power engineering, which is going to be very critical to the industry going forwards. Lots of interest with the control of kinetic devices and rotating machinery, variable power system integration, all of this kind of renewable energy technology that is going to be coming onto the grid in the near term with solar and wind and potentially water power is all variable in the sense that it drives its energy from a resource that is variable, the sun and the wind and the water. And so we have to figure out how to control these things, especially when we look at higher renewable contribution power systems. And so how do you control these? The wind and the sun happening at different times, but we always like our light bulbs to go on when we turn them on, not when the wind is blowing or the sun is shining. So lots of very fun things that could be done with this technology outside of putting it up and looking at it from a wind energy perspective. So we just want to kind of open up thinking and make sure that when you see the title of this, that you don't think it has to be focused on wind energy, because there's lots of fun research work that could be done, experimental work that you or your students could be doing in this whole sector of new energy technology. So let's go to the next slide, and this will talk just a little bit about the research grant. So through this, you apply for a research opportunity here, and we'll provide turbines, so these turbine packages, and then we'll also provide a $6,000 research grant. And that's to fund the setup of this equipment, basically whatever you want to do with it, whether it has anything to do with installing a wind turbine on your campus, or just some experimental setup so that your capstone students can have something to work on from a power electronics standpoint. So the $6,000 research grant is just to cover costs for this additional work. We do have a list here of some of the kind of things that you could spend some of the $6,000 on, or if you have these as part of your academic institution, then some of the things that you might think about needing or wanting to be able to do, either with the money or with stuff that you might already have in the shop. Don't need to go into any further detail there. So a couple of these kind of specific research ideas, Charles mentioned some of these already, but if you're going to plan on using it for wind-related research, Charles already mentioned the power curve of the turbine. So verifying what that power curve looks like, and that would be looking at the wind speed as well as the power that comes out of the turbine and how that changes over time. And so a very interesting thing that one can look at. Confirming the cut in and rated power of the turbine. So this is when it starts, what wind speed it starts at, when wind speed it stops at, and then how does it control power as it got up in wind speed. Obviously, as the winds keep getting stronger and stronger and stronger, you don't want the thing to keep spinning faster. So it has to have something that stops it from spinning. And what is that? How does that work? How does a turbine figure out how to do that? And how do your students maybe work with the controller to change that? This regulation of power and how does it regulate power as it continues getting faster. Looking at how much energy you might be able to produce out of this unit, either where you are or different places around the country. Again, the nation is moving more towards the use of renewable energy. So understanding how much energy different technologies can provide you in different parts of the country is going to be critical for power engineers going into the future. And then how could you calculate energy savings? So how do you go from that we're producing power here to actually how much energy we're saving and how much money we're saving because of that? All of these are really interesting questions, specifically around renewable energy and wind energy in this case, but can be applied across a pretty broad spectrum. Next slide. And then just some other research ideas here that we can look at. And here we have a student, got an example of a student who's using the generators from small turbines to do other work. And in this case, they're putting a gearbox in between it. So how do you raise or lower the rotational speed of the shaft based on different conditions? So there's lots of interesting work here that you could do around the wind turbine design, but then also going beyond the wind turbine design. So just to give you a couple of ideas of how to think outside of the box when using this equipment, if you're not in a position where you could install it outside of your campus or kind of in a research platform like that.
Wonderful.
So back to you, Remy, to talk about the grant itself.
Yeah, thank you, Ian, and thank you, Charles, for all of the technical information. As part of the proposal, the other thing we're asking each of the schools to think about is some ideas for outreach. And so these are just some ideas of different ways you could engage local schools in your community and some of the work that you're doing. You could invite local schools to your campus to learn about your research. You could visit a local school to teach them about renewable energy. And we have a ton of curricula suggestions. So if that sounds like something you wanted to get into, we would be happy to help you build that. Hosting a local outreach event about renewable energy on your campus or in your local community to just engage the community would be amazing. Giving a presentation or having the students give a presentation on their project and its findings, maybe at like an open house where they bring people to campus and they demonstrate what they've been working on. One of the other big issues around renewable energy and developing our workforce is just that career awareness. So if the students wanted to create a career awareness video or presentation to either give to local schools or post on your YouTube channel and share it wider, that'd be fantastic. Participating in another local community event like an Earth Day or a solar farm, a solar tour that's coming up or something that's going on in your area would also be great. So there's just lots of different things that you could be doing to take that broader impact of what you're working on from a research perspective and making sure that kids and the community might learn something from that. So with that, I kind of wanted to go into some of the other opportunities that come along. So we've talked about with this grant, or project, you would get the equipment package, and then you would get the small research grant. The other things that Repowering Schools is offering are informational webinars that would happen twice in the semester. And this research is aimed to happen in the fall semester of 2022. Yes, gosh, my years are crazy. And so within that semester, we'd offer some informational webinars, maybe about wind resource analysis or some topic related to the power system that we think students would find interesting and helpful. Again, that's optional but encouraged. We'll also offer the opportunity to gather monthly on project calls where teams will have the opportunity to share about their progress with their peers. And then we would invite industry mentors to also be on those calls to be able to give feedback and advice on the progress of those projects. And then lastly, we mentioned at the beginning that there will be an opportunity for the students to present their research as part of a student symposium at the Distributed Wind Energy Association conference that happens in Washington, DC. That happens usually in February, and the next opportunity would be 2023. And the cool part of all this is that FedEx does have a local solar powered facility in the area that we would also be able to tour as part of that. So it would be a really neat opportunity for students to present and then also get to tour some neat facilities. Travel scholarships can also be made available, and you can put some of those research funds towards that travel to that as well, if you'd like. So now we'll get into the details of the proposal. So this all sounds fantastic. How do I get it? How do I get this project proposal and get the money? So we have a relatively basic application. It's a Google form where we're going to collect your information about you as the PI for this proposal, as well as the school information. You're going to be asked to upload a 3-page project proposal where you're going to outline the research project that you're planning to undertake with the equipment given, the diversity of your team. Again, we are encouraging multidisciplinary teams. So we want to hear about that diversity, academic diversity, but also other diversity. And then explain your outreach plan, which we just talked about some examples. And then lastly, we want to hear about how your institution is supporting this. And then with that, you'll also upload a 3-page academic program description, which is where you're going to talk a little bit more about how this research project integrates into your research program and your academic program at the school that's currently there. So how is this going to enhance and benefit what your school already has? And then lastly, you'll be asked to upload an institutional letter of support. And then if you have industry support and community support for your outreach plan, you're welcome to upload those, but those are not required. So like I said, it's a relatively basic proposal. If you have questions, you can always ask me, and my contact information will be at the end. This is the scoring criteria by which we're going to be reviewing and judging the applications. There is the ability, I think we're planning to support up to 10 colleges, universities, and community colleges in this first round. And they will be reviewed based on their innovation of their research plan, their academic support, the educational objectives, their community and industry engagement, team diversity, and programmatic diversity. And like I said, if you have any questions about what that all means and how we're really going to get into the nitty-gritty of that, you're welcome to email me at any time. So with that, again, here's the form to apply, and there's our email address if you have any questions. We look forward to hearing from you and seeing many applications. Does anybody else have any last words of exciting things they want to say before we close up? You're on mute, Charles.
Thank you.
Yep.
I would add a couple words on the wind resource, because in describing what we mean by when we say wind resource assessment, I think it'll give people maybe some insight into the flexibility of this program. Typically, when most people think of a wind resource assessment, they think that you put some measuring device outside and it measures the wind speed and direction, records it, and then you do some statistics on that. And that is a That is, in fact, the definition of a typical wind resource assessment campaign. The difference between what we're describing here and that would be that there's also wind resource records out there. So Texas A&M, for example, has databases that you can download of the wind resource at their site on a 10-minute basis. And so you'd say, well, why would I want to do that? Well, because there's some science around that, where it's not just 10-minute data, but how do you convert that into some sort of a probabilistic perspective? Like, what is the probability of any given wind speed? And then how do you convert that, as Ian was saying, to estimate the annual energy production from anything? And then there's also interesting analysis you can do that you can say, well, what is the shear? So shear is about how much is the wind speed increasing as you go higher above the ground. And we all know that if you're standing on the ground, it may not be very windy, but if you go up a tower, climb a tower, or stand on the roof of an office building, it's windy up there. So how is that? What is that relating to? So any wind resource campaign, resource assessment campaign, doesn't necessarily need to be done on site. That was the one thing I was going to say. And you can partner with other campuses that may have equipment, or NREL has live streaming of wind resource coming off of the M2 tower or something like that. You've got one on the west side of campus. So don't think because you live in not a windy area, or you're in a city or something else, that this isn't available to you. There's all kinds of ways of accessing it and making good use of it.
Definitely. Thank you, Charles, for that. And yeah, and I think the biggest thing is we can just reiterate the idea that, this equipment package could serve many roles and have many possibilities outside of just being an installed and monitored vertical axis wind turbine on your campus for testing purposes. So I hope that this has given you some good ideas. And like I said, we'll reiterate to please contact us if you have more questions. And we'll look forward to talking with many of you soon.
Thanks, Remy.
Thank you, guys.
Everybody.
Yeah, good to see you all.